So today we're going to look at factoring polynomials. The previous lessons, we were multiplying our polynomials together. Factoring is actually the opposite of multiplying. We are going to go back to the original factors that were multiplied together to make our polynomials. And the first type of factoring we're going to look at is GCF, or finding a greatest common factor. So the greatest common factor, GCF, of the terms in a polynomial is the greatest monomial that divides into each term without a remainder. The one thing, number, it could be a variable that would divide evenly into the entire polynomial without a remainder, would be our greatest common factor. A factor is any number or symbols, meaning like variables, any numbers or symbols that are multiplied together to create the product. Factors are the things that are multiplied together to make our product. So for example, 2 and x are factors of 2x because 2 and x are multiplied together to make 2x. Factors are the pieces that are multiplied together. So when we're looking for a greatest common factor, we're looking for the biggest one that they have in common. So let's look at just some examples, get us warmed up with GCF. Number 1, what is the greatest common factor of 6 and 39? So I'm going to make a list here, 6 and 39, and I'm going to list all the factors of each of those. So the factors of 6, the things that can be multiplied together to make 6. 1 times 6, 2 times 3, and that will take us to 3 and 6. Are there any others? I don't think so. So let's list 39. We can multiply 1. 2 does not go evenly. 3 would divide evenly. And 3 times 13 makes 39. And then, of course, 1 times 39. There's not a big list of factors here. So what would be the greatest common factor that 6 and 39 have in common is just 3. It's not very exciting, but GCF of these two numbers is 3. Let's look at number 2. What's the greatest common factor of 8, 12, and 40? I'm going to do the same thing. I'm going to list them all out so we can visually see what their greatest common factor is. Factors of 8, we can do 1, 2, 4, and 8. All divide evenly into 8. 12, 1, 2, 3, 4, 6, and 12. 40 is a little bit more, right? 1, 2, 4, 5, 8, 10, 20, and 40. I think we got them all. All right, so what is the largest one that they have in common? Notice like they have 2s in common. We're looking for GCF. We want the greatest that they have in common. So 4. The GCF of 8, 12, and 40 would be 4. So let's actually do some factoring with polynomials. So we're going to take a polynomial and look for a GCF and then factor it out. For you, this is like doing backwards distributive property. We're going to pull the GCF to the front, set up some parentheses, and show what's remaining inside. So it says, when factoring polynomials, always check for a GCF, that greatest common factor, first. This is our first step in factoring. As we build through our lessons, I want you to always check for a GCF first. This will help you make your polynomials smaller before you dive any deeper. If the polynomial has a GCF, divide it by each term. So the directions say factor the expression completely. Number 3, 27 plus 9x. I'm going to list the terms to the side. I'm going to do a little bit different than we did before. I'm going to show that 27 is 9 times 3. And then 9x is 9 times x. So their GCF is going to be a 9 and only a 9. I cannot also claim the x because they don't share the x in common, but that is coming up. So our GCF here is going to be 9. So it can be one of the numbers. If one of your coefficients or one of your constants divides evenly, that can be your GCF. So we are going to take 27 and divide it by 9, and we're going to take 9x and divide it by 9 to create our new factored polynomial. So put the 9 GCF in front and set up some parentheses. When you do 27 divided by 9, what do we have left? 3. Use the same sign. This is plus 3 plus 9x divided by 9 leaves us with x. When you remove that GCF of a 9, you have 3 plus x left over. So here is your factored form, removing that GCF, 9 times the quantity of 3 plus x. If you're ever unsure as you're starting to factor for the first time, guess what you can do? You can check it. You can multiply this back through, do distributive properties. So I'm going to check right here. Quick check. 9 times 3 is 27. 9 times x is 9x. And we got back the original polynomial. So all we're doing is kind of dividing. We're factoring it down. We are finding the things that were multiplied together to make the polynomial. So 9 times the quantity 3 plus x. Let's move on to number 4. 12x plus 4. I'm going to list those terms here. I know that 12 is 3 times 4, and we also have an x in that term. And then 4 is 4 times 1, but I see that GCF can be a 4. So we're going to take 12x, divide it by 4, 4 divided by 4, and to show our factored form, GCF is the 4, and I'll have parentheses. Like I said, backwards distributive property. So 12x divided by 4, what's left? You can see where I did not circle, we have a 3x left over. I could also divide over here and show that 12 divided by 4 is 3. 3x is left over, plus 4 divided by 4 is 1. So you got to keep a placeholder there. Sometimes students remove a GCF and they're like, what do I put there? Do I put a 0? Oh, no, we don't want to put a 0. Let's check it really quick. 4 times 3x is 12x, and 4 times 1 is 4. And I got back to the original polynomial that we started with. So there's your factored form, 4 times the quantity at 3x plus 1. Let's move on to the next example. Number 5, 40x squared minus 48. Do the same thing we've been doing. We'll list the terms here. Now, what could they share in common? What does 40 and 48 share in common? Can you already start thinking about your GCF? I know that 40 is 5 times 8, where 48 is 6 times 8. So a GCF of an 8 would be the largest factor that they have in common. And don't forget these x's. We are going to start dealing with x's in the next example. So their common GCF here is 8. GCF of 8. So we have 8 times, what do we have left? A 5x squared minus, when you divide 48 by 8, we're left with a 6. So final answer, factored with a GCF of 8 times 5x squared minus 6. You can check it, multiply back through, and I'm going to get that 40x squared minus 48. Let's try number 6. 5x plus x squared. Now, looking at this, I see that there's 5 times x. Wow, really exciting. For x squared, that's x times x. So what do they have in common? What factors are multiplied that they have in common? A single x, just one. So a GCF of x. So let's show that in factored form. Pull out that x. What's left in that first term? 5x divided by an x would leave us with just 5 plus second term x squared divided by an x leaves us with just x. There is your factored form, and you could check that. X times 5, 5x. X times x, x squared. We got back the original polynomial. Number 7, 6x squared plus 9x. Going to list those out. All right, so 6 and 9 would have a GCF of a 3, right? 2 times 3. And let me show in this first term we have x times x. 9x, we could show 3 times 3 times x. And they have a 3 in common. They also have an x in common. Our GCF is 3x. So 3x times first term. If I take 6x squared and divide away 3x, what would be left? Let me show you. 6x squared divided by 3x. You can also see what's left that I didn't circle in our list. We're going to simplify the 6 and the 3 and get a 2. Take away an x from numerator and denominator. We have 2x left over plus second term. When I take 9x and divide away this GCF of 3x, all that's left is a 3. You could check it, multiply back through. 3x times 2x is 6x squared. 3x times 3 is 9x. Got back the original polynomial. Number 8, 10x to the 5th, and then minus a 2x. Notice I don't really care that it was minus 2x. I'm not going to worry about like a factor of negative 2x. I'm just going to find my factors and I'll apply that minus sign in my parentheses. So 10 and 2, number-wise, coefficient-wise, a 2, right? So we could have like 5 times 2 makes 10, and we have 5 x's here. In 2x, we could just have 2 times 1, so 2 times an x. So they have a 2 in common and an x in common. GCF for number 8 here is 2x. So setting up my parentheses, what's left from our first term, 10x to the 5th divided by 2x, a 5, x to the 4th. 5x to the 4th minus, this is a subtraction polynomial right here. The second term, the 2x was divided by 2x. What did we do last time? When the entire term is our GCF, we have to use a placeholder for 1. And you can multiply that back through using distributive property and see that we get back the original polynomial. Number 9, let's get messy. Woo! 5x squared y squared, 3xy. What do we got going on here? Well, 5 and 3, like our coefficients of our terms, 5 and 3 are not going to have common factors. So I'm not going to worry about them. We do have 2 x's and 2 y's in our first term. 3xy is a 3 times an x times a y. What do they have in common? A single x and a single y. So our GCF for number 9 here is xy. What's left over from the first term? We had a 5xy. Plus, second term, what's left over from 3xy? We took away the x and y, so there's only a 3 left. Factored form, GCF was xy times the quantity 5xy plus 3. We could use distributive property. Remember, x times x will be x squared, and y times y will be y squared, so bringing us back to our original problem. Number 10, 20x squared y squared, and then a 4xy. Let's see what we've got going on. Coefficient-wise, we got a 20 and we've got a 4. Well, I know 4 goes into 20, so let's rewrite 20 as 4 times 5, and then we show the 2 x's and the 2 y's all expanded out. And then I'm going to use 4 as my GCF. So in the second term, I'm just going to show 4 times x times y, kind of like our last problem. So our GCF is a 4 and an x and a y. Oh my goodness, the whole thing. GCF is 4xy. So what does that look like? Pull that out and set up your parentheses. What's left in the first term? From the 20x squared y squared, we have a 5xy left over. This was a subtraction problem, so don't forget minus what's left over. We took all of it as a GCF, so we need a 1 as our placeholder. And there is your factored form of that polynomial. Again, you could use distributive property to work it back out and see if you get back to the original polynomial before you factored it. So this is factoring polynomials. First, looking at just removing a GCF or greatest common factor from our polynomials. Guys, factoring is going to be a huge theme. It is going to be a skill that you are going to need through the rest of Algebra 1, and you will definitely need in Algebra 2 as well. So please digest this and practice this because this is not going away anytime soon, especially, like I said, it will continue into Algebra 2 later in your high school career. So check these out, practice, practice, practice. Let me know if you have questions, guys. This is GCF, and we're going to keep factoring a couple other different types of polynomials and bring it all together so we can factor any polynomial. So I'll see you in class, guys. Let me know if you have questions.